Computer Startup.
This video is more about the details related to the last video, fine-tune LLM foundation models with InstructLab, and open source project introduced by IBM and Red Hat. Here we did the setup and a little bit about the introduction, what the InstructLab has with the navigation to the related resources. And now we are going to inspect how that works on a local machine, how to set up all that stuff really to contribute or trying to contribute, check out how it works, doing some sample data. And that is what is the objective of that video.
Computer Startup.
So let us take a look here in the next blog post I did. That is now the one with the example about the musician. So maybe you know that I play the drums, I create some kind of music, and I thought by myself, maybe I just try out what will that model, which we out of the box just installed in the last video, say when I ask the model about myself, what do I get as an answer? So let's see what that is. So is it still running? Yeah. So let me see what happens when I asked. TrainML appears to join. You joined the site on third. However, research, I'm unable to find specific information about this user and the name and joining date. Oh, that is interesting. Maybe that is interesting. It seems that it contains some information about that, and it is not clear about. It is more than the last one, because when the last time when I asked that question, I got a different information, but maybe when I ask it differently, so once again the same information, maybe I do appears, yeah, it's still the same. Oh, that is very interesting now. Okay, it's not so wrong, and I guess maybe that is true. Okay, so let's. So I'm a little bit wondering now that is maybe some updates of the model itself with some other resources. In the last time, it said, who is T&M drummer? It's Thomas Lang. So Thomas Lang is a really famous drummer, and he's, I would say, incredible good. And he said that the model said known as my my name. So I would say I'm sorry that I'm not one of the best drummers of the world, and that was not true. So the question is now how to configure the foundation model. I know that is not a really important information that should be in a foundation model. It is only an example to find out and a little bit get familiar with the situation. So when we go into that, then we need a little bit to dig a little bit more into the information what we already got, or maybe when you have read my last blog post, or maybe you have seen the demo video, the very good demo video from Red Hat. Here is a little bit about the content. What are the steps to do that? It is preparing the taxonomy tree, yeah, and that means inserting data, yeah. So where we want to insert the data in the taxonomy tree inside that taxonomy project. So let me open up the taxonomy project. That is the taxonomy project. So in here we have different areas: knowledge, foundational skills, compositional skills, and here we place the data, yeah, where the foundation model should be trained on, yeah. So, and that is what we downloaded the last time on our local machine, and now we are going to use that. That means we prepare where we think about, okay, where does that make sense? Then we need to validate if is there any technical problem with that, with the configuration we provide. And then we generate synthetic data in case if we do not have enough data, and I know I don't have enough data, and it is an example. So then we can create synthetic data. So, you know, when you do some fine-tuning, you should have at least 100 examples, yeah, generate them, then we're going to train, then we test the model, we convert the model, yeah, so that we can run that locally very easily, and then we serve the model, and then contribute the changes. I will not contribute that change. And yeah, here is that about the summary. Here you can see a little bit about the information about the configuration with the model, what we already had. That are the different kind of models which are used in the several sections. We have the chat when we interact. Then it's about the general, about interaction information, and then generate that when we're going to generate the syntactical data, which model is used, and so on, and when we are going to serve, which model is used. So that is everything what the starting point is, and now we're going to prepare. When we now are going to prepare the data, now we need to take a look where does it make sense in the context of the taxonomy tree. So a little bit about the taxonomy tree, the Wikipedia. So that is how the tree is structured, which makes logical sense, therefore classification and categorization. And that is what we see here in the taxonomy tree. When we go here to the knowledge, we see the different organization, humanity, arts, and so on. And that is what is given in that example. So now let's see what are the next steps. I think it makes sense that I insert into music some kind of artist and trademark, and on my name TNM Drama is really a trademark, yeah? And that is here I can add that as an information. So that is where I want to position my information. Then we need to generate a question answer, a YAML, yeah, so that is used later to generate synthetical data, yeah, and then we need to specify resources, yeah. When we have some questions, especially when we put it into the knowledge information, some resources to a reference to, and that is cool that we can specify a GitHub project with the specific information of a commit. Yeah, what should all used? Yeah, that are the patterns which are used for the basic information. So then we can see that then where the domain is where we want to add that information. Yeah, and after we know where all the data comes from and what is the resource to generate the synthetical data, it comes to the truth. When we going to contribute a foundation model, we want that foundation models are trustworthy. And one way to be trustworthy is that you know everything is valid, who is responsible for the data, who has given the data the license, not violate any any law and so on. And that is what is about in the attribution file. And here you have several entries you can have in that file, saying, okay, where does that data come from? The information I contribute is validated. So when IBM also can check that and validate the information, or others can also validate the information if that is true. And yeah, reliability is important with data. And that is what we have with a full transparency, and that is what is good, very good, that you have a full transparency for that. Yeah, and with all of that, I would say before we start with all the other, I think that is what we now can do in the first step in our project. So the project is still open. We have here the taxonomy tree. So we can go to the taxonomy tree and the knowledge, and let's see where the knowledge is. Here was there, I need to verify when I had a knowledge music. Wasn't here's music. There's only event, as you can see. And now I insert here a new folder. I can also do it here. A folder called artists. And under the artists, I say trademarks. So, and here we will place our files. So, our files, I will create a file called here with that question answer. That YAML. So, and now we see here that is what I have prepared from my side as questions. So we can insert that. That is the information of that YAML. Yeah. So we have that now. 5 at a minimum. We have 5 examples here. And then we see the task description, what is needed here, the questions related to the artist, so that is what I gave here. And then when we use here knowledge, we also need to provide some additional information. The information here about a repository which contains accessible data, official accessible data that we can use as an input. Yeah, when the synthetical data is generated, and that uses it as input for the question and answering. Yeah, to get the context. Later on we will see that, so let's add that. Maybe change the commit ID. Yeah, I know that. Yes, here, copy. Here is it already. Let me see the new commit ID. Last commit ID, so with the newest data I provide, I will all files with markup language will be used. Yeah, so I have 2 of them here, and yeah, okay, and that is what is the data resource. And the next is that we need to create a contribution.txt. And that file here, I just say that, and as you see, that must be really validated by yourself, and yeah, be honest and ensure they have all the licenses for the data, and that is what is important also as an input then for later on, that really it can be contributed to the model. So with that, we can go to the InstructLab. So we have already opened up, but maybe here I'll open a new terminal. Yeah, I don't need to do that with that. I also need to activate once again. Yeah. And now we have a functionality which is called ILab Taxonomy div. And let's see if everything is right, if something is missing. So the taxonomy is valid. That means only it's technically right. It does not mean that the content is right. So that is what we really need to remember. And yeah, we have seen that. And now, with that input, we are able to generate data, synthetic data. And let's see again here. So what is here in our folder structure, and if something has changed. So for that, I really exit. So I just exit the rest, so that so we have not running the model. So so the model is not running. Yeah, with that, now we are ready to generate the synthetic data. Let us take a look here. What will happen now? We will generate it. We will create some JSON-L files with the information here. So as we know, out of the box, 10 data entries will be generated. We can see here where's the amount that is configured in our config. Yeah, so that is the number of the instructions, and that is the amount of the examples. And here we have the rest on the information. So that is what is given, and based on that we will just start and try that out. We can now just invoke generate data, and a new folder will be generated called generated. It must appear here. So we insert it here, and now we execute that, and we can see in a few moments now the folder was created, and then the files will be generated. Let me also take a look into the files, and that process takes a while. Now we see the instruction. Yeah, instruction. What kind of music does? So that as an input and creates all kind of music, and that looks good. Yeah. So, and then we will see the generated, the test data, and the train data. So here we have some test data which is at the moment generated. We can see that was the system instruction, yeah, what the user said and what the assistant replies. So, and that is now the process of generating the synthetic data. And when we take a look, now we can see the name of the song, and that is really a song I created. Yeah. So let me take a look here. When we see here, it was the album, specific album will be, yeah, That was the question. Generate instructions should be similar to provide examples. For example, you can ask the genre album a specific song was created, that there are some instructions how that can be. And now we can see insert generated what the instruction was. So that is what is the name of the song? What is the name of the song of Lazy Day? Lazy Day, that's the name of the song. Yeah. His song, his track, album, chill out. Oh, okay, that is not, okay, that is not right. Yeah, that is not right. And here you can see where the input comes from the GitHub project. Yeah, so we have related the GitHub project with some MD files, and that is the contact here as an input, and then we move on with all of that, and that takes a while now, and that is the process now, how that works. And yeah, how is it defined? Reflect the beauty of nature. Yeah, so in some cases it really works good. It depends also what information it has. So as more information you have, the best will also be generated on the data, on the synthetic data. And yeah, I'm not a famous one. I registered that as a trademark, but I'm not really active or a professional musician. It's just like I did it because it was a wish from my childhood, and that is the reason why I created that. And yeah, so with all of that in mind, so I will now cut the video and come back when the training is done, because that will take some minutes. So now I'm back. It took 36 minutes until it finished. Now we have the entries, and we can see the instructions that was generated here. Then we have the log is still there. There is no change in that. The model information, so nothing in addition was created. So that is now the data ready to train the model. So let's see what are the next steps. So now we have generated the synthetic data. The synthetic data is available. Yeah. Now we should inspect also the synthetic data. Is everything right? Yeah. So we can see maybe here's information about some lyrics I wrote, and yeah, that is good. That works. But I think there are maybe also some entries which do not so fit, yeah. But verifying all of that, it really takes time, and so I do not spend that time now, because it's just only about to show that how that works. But in real life, yeah, you must validate your data and know, okay, everything what you are going to contribute, and also the generated one is valid related to that what you want to do, and especially also the training data itself, yeah. So, and now with that, let's see here. Now with that, we are, yeah, in a position that we can now train. And the next is only really just insert training the model. And that will now use the low rank adaptation, LoRa, inside that framework. So Llama CPP and lower rank adaptation is used in that framework framework in the CLI of the InstructLab here. So, and now I just copy that and I can insert that here and run that and see if anything is generated directly at the beginning, and it will take time again, and I guess I need to do some cutting in the video. So let's start. So it's all out of the box. We have seen now the taxonomy data was generated, yeah, and we see here the training data which was generated from the information. Yeah, so we have now the entries we are going to use, and also for the validation. For the validation we used 21. So that's there, and that will take now a while. You can see this training has started. At the moment, the file itself, oh yeah, it started. Now you can see here that is about starting the basic file, and then we will have the trained one and the trained model. So, and with that I would say now I wait and I do some cutting in the video. See you after the training. So now I'm back. The training has finished. Let us take a look here what happened. Here we can see the model was downloaded and the new model was trained, and now it is ready here with a quantization. So, and yeah, that was that task. These two folders were created for the download, the model itself, and then for the training and the quantization. So here we have it created. So that was the these were the steps, and now let's see what will be next. The next is, after that we go to test the model, and for that we will run iLab test or model test, and as we know, the data for that is already given in our project here for the test here, and now I just can insert that, and let's see how that will be executed. So you can see that was given here, and then we can just execute that. The most time what we have to do is just wait and now let's see and inspect a bit during the execution how the test looks like. So now the test is started. We see the testing, and what a cool thing is, during the execution we see the comparison between the before and after. So that means the output after training and the output before the training. And that's cool, so that we can see that. And now see that was skipped, generated before the training, special tokens SB. So let me see the training output after the training. The artist known as is, yeah, so it's about me. And then you can see before it was not known, yeah. That was here before the training. So okay, we have some progress with our training, even if it's not perfect. But it works a bit, yeah, so that's cool. Artist known as TNN, so yeah, that is good. And before we can see the generated, so before the training, names from its creators. Yeah, that was totally wrong, so it's nothing about that. Oh, oh, yeah. Output after, it's still, that's still wrong, yeah. And that was before. Repeats with charges, yeah, that could be, and that is still the same, not totally the same, but that is more precise, so that would fit. So because that are really songs I participated in the creation, and that was an overall that could be right from a high level perspective. And yeah, so it's not bad. Oh no, oh, we are also finished. So, and let's see, is there that was data, it was just generated. So we have here the output. So is there anything that was in the output that is not was not routed to any file? So we can use a pipe to do that. To that we have that result also in the file. So that was good overall. Yeah, so I like that. The training data. So we had taxonomy models, so that are the folders we now have. And the next now, after the training and the testing now, we can go to convert it to a model we run here on our local machine. So that is, now we convert the model in this GGUF format, yeah, and then we run it on a local machine with the InstructLab based on the Llama CPP. So let me convert it, and we can remember here the basic configuration is given here. So when we convert it now, we see a new model output file is created for that, for the conversion, and I guess that takes a little bit time. So I will now also cut the video now and see you after the conversion of the model. So the model is now converted, and we see that's done. So it has deleted the unnecessary model, yeah, so, and we see very clean the model, the starting point and the trained model, and we have also the file here. So, and with all of that, now we need to specify when we run again, when we want to serve now the model, where the model is located. No, we got that. So, and now we need really to set here the model path. For example, that is how we can do that. I put that now here. see that? It's easier to copy directly from here. Copy relative paths. That's much easier. Don't need that, so it's currently in that folder, and now we can serve it and see what it says after the execution. So let's see what happens. Here we know, okay, we will be not be notified. So, and now chat with the model. A short update here is that we should also insert here the word model. I also updated that here in the blog post. The command has a little bit changed. So where is it? Is here, so that the update with lab model chat, that was before, and now with that, and that is the update. And now we serve it. We already serve it, and now we chat with that model, with the location, and now see what happens when we just take one of the questions we now we have with the test questions. Let's see. What will be the answer? Okay, that is interesting. That because the testing was better. And I do not know what the reason for that is, but you see, you need really to inspect, you need to test, to train, to verify, to do that in the chat, in that context, and that is. And when you finished with all that work, then you can decide to contribute to the foundation model. Yeah, using the correct data, and that is the most important thing, using the correct data, the correct licenses. And with that, we all can participate in the community, yeah, from a model which has a broad foundation. And I would say that's all for now. And I hope that was a bit useful for you. And say thanks for watching.
Test, switch.